In this classwork 2, we're going to take this graph and we're going to describe everything about it. We're going to start by looking at the highest exponent. So we expect 4 roots, 4 minus 1, we expect 3 turning points, 3 places for it to turn, and the turning points, 3 minus 1, we expect 2 inflection points. Okay, like we did inflection points in yesterday's assignment. Now, your coefficient is positive, so our end behaviors will both open up. Now we will find the zeros. That will help us figure out where we're turning. So we would factor out an x squared. And again, this is your perfect squares. They will factor again. So you can see that you have, set them all equal to 0. You have a double root here where x is 0. This will be x is 5 and x is negative 5. So when you sketch, you're at negative 5, 5, and a double root at 0. Your ends are going up. These roots are coming through. This one is bouncing off. So you can kind of tell this makes your W. Where it goes, how far down, we don't really know. But we do know that these should be symmetrical because these are both at the 5 and the negative 5. Now, when you put this in your calculator, you will find your minimum points. Point A and point B will be our absolute minimum points. And you'll see the symmetry over the y-axis. So when we get this, point A and go 3 decimals will come out to be this. And point B is symmetric, so it's the positive of this and still in the negative down here. So this point over here, point C, this is a relative maximum. And this was at your 0, 0. Your domain, all real numbers. Your range, we look at the y value of your absolute minimum from negative 1456.25 to infinity. We can do your increasing from here. You're increasing from point A to point C. So from negative 3.536 to 0, you're increasing. And then you're increasing from point B to infinity. So from 3.536 to infinity. You're decreasing from negative infinity to point A. Use your x values. And you're decreasing from point C to point B. Now we're going to look for concavity. Remember to look for the cave. It's going to open down, concave down, or concave up. We've got a concave up here. We've got another concave up here. And right in the middle, we have a concave down. We have to find the midpoint between A and C and between C and B so that we can concave up halfway, then turn and concave down halfway, then turn and concave up. These points, D and E, are our inflection points. It gives us the point midway between A and C. So since it's a midpoint, we take the x values of A plus C and divide it by 2. So negative 3.536 plus 0 divided by 2. This one inflection point will be negative 1.732. And the other inflection point, since this is symmetrical, will be positive 1.732. To find your y values, go to your calculator in your graph and do second calc number 1 for value. and enter the value negative 1.732 and find its corresponding y value. Your corresponding y value will be negative 68.375. That is the other part of this point, of our inflection point. And because we're symmetrical, it's the same for both. From here, you can do your concavities. So you're going to take do your concave down. That's this guy in the middle from here to here. Use your x values only. From negative 1.728 to positive 1.728. You're going to do your concave up from negative infinity to the first inflection point D, negative 1.728, and then from the second inflection point, 1.728, to infinity. So we've pretty much hit all your attributes of this graph.